So, hi, doctors Julia and Wagman. Welcome to BeyondPhrenology.
Thank you for having us.
Yeah, it's my pleasure. I know Dr. Wagman, I met him first time at ICPA International Conference in Minnesota in 2015. Since then, and I haven't met you yet, but here we are.
No.
So, could you please introduce yourself? I know Dr. Wagman has been very prolific in ecological psychology. He's one of those from the Connecticut group. Has done a lot of work on wielding and direct perception of affordances. And together, you just came up with a book on ecological psychology, which I guess is the first textbook ever written on the topic.
I mean, give or take. There was a book back in the 80s called Direct Perception. That was Krell and Michaels, but it's the first one that is since the field has become mature. But yes, I'm Dr. Julia Blau. I also graduated from the UConn group, and I'm now an associate professor at Central Connecticut State University.
And Dr. Wagman, would you tell a little bit about yourself?
Yeah, I'm Jeff Wagman. As you mentioned, got a PhD at the University of Connecticut in the early 2000s, and since then I have been a faculty member, professor at Illinois State University, and I do, in fact, do work on wielding, perception by touch, but also perception of affordances and perceptual learning.
So, doctors, before moving forward, you both mentioned affordances. What are affordances exactly?
Let me see. I used to be able to do the Gibson quote from memory. Affordances are what the environment provides or furnishes, whether for good or for ill. Did I do it right? How'd I do?
I think you did. There are lots of definitions of affordances, and you can get into long arguments with people about the specifics of them, but I think it's safe to say that affordances are opportunities for behavior that emerge from the fit between an animal and environment. So
one can't exclude the other.
Yeah. And what are the implications of it for the mind sciences overall? Is it different than stimulus? Because if you look at most of psychology traditionally and most of neuroscience, it is based on stimulus, right? We present a stimulus to an animal and see the response and see how the brain is processing those stimulus.
So Gibson, who is the one who originated the term affordances, was reacting very much against the old notion of stimulus, because stimulus carries with it the idea that it is a meaningless thing, right? So spots of light or wavelengths of sound, rather than something more meaningful like, can I pick up that cup? And his argument, the one that we follow in the book, was it's useless to start with something meaningless, because why would we have evolved to perceive something meaningless? Of course, we evolved to see something meaningful. And he proposed affordances as being the thing we evolved to recognize. And so that the main idea of the ecological approach is figuring out how it is that the various types of energy can specify the affordances that we need to be able to see. So how can we see a cup is pick upable in the light? What in the light tells us that that cup is pick upable?
I see. So you mean like when I'm kind of lifting my glass, I'm not processing, where is the edge of the glass or what is the weight, and then trying to come up with a motor program. Okay, right. So it is full of coffee right now, so I should produce more force compared to an empty. So don't you think those computations don't exist?
Not according to Gibson, no. And I agree with that. So basically, because the computation that would be required for that, right, is something that right now we're trying to teach computers how to do. We try and teach robots how to do those things. And the number of computations required, the amount of work in trying to to do the kind of computations you're talking about is massive. And it can't just be done once, it has to be done continuously. And at the end of the day, there's just too many things to keep track of.
Yes.
And instead of looking at those, what we call lower order variables, right? What is the edge of the cup? How much does it weigh? How wide is it? We look at higher order variables, which are actually very simple and very few, right? What makes a cup pick upable is something that can be immediately grasped, pardon the pun, immediately seen in the light itself. You don't need to go the extra step of computing it out of the lower order variables.
Right.
And the other side of that is that, the ecological approach tries to develop an understanding of perceiving and acting and even thinking that is continuous with all animals. It tries to develop an explanation that fits the achievements of all, maybe not even all animals, but all organisms. And so to introduce computations at any point, if it would mean that you would need to do it across the board. And so if computations are how we perceive, then computations are how, worms and snails and amoeba perceive too. And I think that that's just a much harder, maybe it's possible, but it seems to make it much more challenging. And it seems like an unnecessary complication. And we might be able to do a lot better and go a lot further without them.
So rather than suggesting that slugs are doing higher order physics, it's easier to suggest that we're all doing a very simple detection.
Yeah, so last night I was watching some YouTube shorts, and one of the videos came up what was about tardigrade, those water bears, and how small they are. They're probably the smallest creatures which can walk on 8 legs. And these are microscopic, and they're walking and they kind of interact with each other. And I was suddenly thinking, like, okay, do they have internal model? Do they have representations? Because it's hard to imagine that those organisms might have representations. So then the next question is, okay, let's assume that the brain is representational, the way computational ideas endorse. In that case, when in the whole evolutionary kind of hierarchy, do representations came into play? So is it kind of a strict divide between representational cognition versus non-representational at some point? Do we understand those substrates which are required for that? And kind of opens a can of worms as soon as you think in those computational terms.
And it doesn't stop there. You're talking about a multi-celled organism, but you can talk about single-celled amoeba who are capable of building houses out of little pieces of silt that they glue together with their spit. They can build themselves houses whenever the surrounding area gets dangerous. So, you'd have to be saying that single-celled amoeba with no brain at all is doing representations. It just doesn't seem to work out.
And there are probably representations in some aspects of human life. But, the Gibsonian approach is that but if they exist, they are not intervening in the perceptual process. They are not a necessary component of how we perceive and act. If they exist, they are layered on top of that. They require direct perception. They require this contact between animal and world for their own existence. I think there's a Michael Turvey quote. I don't know if he was exactly referring to representations, but it's something like representations they're parasitic on a more direct relationship. That they might exist, but they're there only because this direct perception relationship is there.
Yeah, that's a more flexible. I guess that makes some room for representation as well, which.
Well, there are representations. It's the question then becomes, what form are they? You know, I
Yes.
make notes to myself on paper. That's a representation, but do they? So certainly there are representations. Are there mental representations, and what are those things like? I don't know.
It's not that the ecological perspective disallows representations, it just disallows them as a solution for perception, action, and cognition, in a broader sense. So
Right.
it could be allowed, maybe, but it's not going to be the reason we're able to see a cup is pick upable.
So since you said perception, action, and cognition, if I remember that your book is about perceiving, acting, and cognizing, right?
Yeah.
So what is the switch from cognition to cognizing implies? I think that's very critical to your theory and what the book talks about.
We've gotten this question before because it's a made up word, of course, but we're allowed to make up words. That's the rules are. When you write a book, you can make things up.
Yes.
No, I'm joking, of course. Perception and action are what are usually used to describe these things, but that makes them into nouns, which means they are outcomes, right? They're finished. So perception is a thing that is done. Action is a thing that is finished. Cognition is a thing that is finished. But they need to be verbs because they need to be ongoing, right? So it is not just perception, it's perceiving. It is not action, it is acting. And there's just no word that already fits into turning cognition into a verb. So we just made it up and said cognizing, because the notion is, particularly in a Gibsonian thing, is that there's never a point where it stops. Action, perception, cognition are an ongoing and continuous set.
Yeah.
So that's why we made up the word. But we've gotten more than one person suggesting that.
No, I'll give you the credit because I've done it myself. So, I have done a lot of work on tool use, and people talk about tools. And me and Dorothy Fregesi, we transformed the word. Now we call it tooling because it's an active activity, right? And you cannot look at passive tools as tools. They become tools only when you start using them.
Yes, love it.
I like that quite a bit. I like it's useful from based on what Julia said, because it's never finished. It's a continuous process. But I also think it's when you start thinking about those things. And by the way, we could have used the word thinking instead of cognizing. We made it, but because there are no courses on thinking psychology, only on cognitive psychology. So we went cognition. But when you start thinking about these processes as processes,
Mm-hmm.
It seems like a lot of the classic problems of psychology either vanish or become less problematic. Because if you say, so, if you think about memory, you start looking for memory. Where is memory? What is memory? Where can you find it? What does it look like? What are its properties? But then if you say, no, we're talking about remembering, you wouldn't look in the same way for the same thing. Now you're talking about a process, and a process can't really be localized. And so it becomes a very different strategy. And we feel the same way about perceiving and acting.
Right.
It's not an output. It's not an outcome. It's a process.
Mm-hmm.
And that also means other things like it means that it can't be an output, or an outcome can be incorrect. But a process is never incorrect. It changes how we think about these things. We can't evaluate perception. This is the way people use illusions to say, oh, well, perception is wrong. Well, is it even that kind of thing? Would you ever, we wouldn't say that, the rain is wrong, the lightning is wrong, the earthquake is wrong. It might be unfortunate. There might be something that happened that was not preferred, but that doesn't mean that it's wrong.
Right. Like rainbow, right? Like rainbow is not an illusion. It's coming out of some properties of interactions in the way you perceive, right? And not necessarily all animals can perceive a rainbow.
Right.
And it's a process.
And it's a process, yes.
It's a continual process that emerges and fades. So I think that's a good example. It's rainbowing. How about that?
No, I like that. So, so in that case, there are so many examples. Like if you ask me, some stanza from some song, it's so hard to remember, to recall. But at the same time, when you start from the beginning, like the whole song. So there's an active process of remembering that middle section of that song actually goes on.
I think that's not just about a process, that's about an embeddedness and a context dependency. Those are other really important parts of ecological psychology, that perception is not independent, or perceiving is not independent of the context in which it occurs.
Yeah,
it's embedded, it's embodied, it's enculturated. All of those things are not add-ons; those are baked in. That's the way it is.
I think also our deliberate inclusion of cognizing with the other two was to put it on that same footing, right? To say you also cannot remove cognizing from that embedded, embodied situation, right? It's going to follow those same structures because it's all of a piece. And cognition has been historically treated as something that is happening inside of the brain, outside of any context. Right. And from an ecological perspective, that's not what cognition should be. So, or cognizing rather. Right. So of course, so that's why we put it on that same footing as the acting and perceiving, is to make sure it's clear. These should all follow those same things. They should all be embedded and be part of an animal environment or organism environment relationship, rather than in any way separated from that.
I think one of the reason I like your incorporation of the term was, a lot of times when I read work in ecopsych, it talks about a perceiving and acting organism. And it kind of makes you question a lot of times, like, so does it mean that nothing is happening inside the brain, inside the central nervous system? So now probably, in the next article, I would be using term perceiving, acting, and cognizing organism. That makes it more complete.
Spreading it. I love it.
Yeah. So you mentioned memories. Could you elaborate a little bit more on memories? Because one of the complaints which people have with the ecopsych community in general is we generally do less with more representational hungry problems, which people call, for example, memory. Like the traditional ideas of memories are extremely representational. And a lot of our paradigms do not have a lot of memory component baked into it, neither short-term nor long-term. So do you have some examples of work which I might not be aware of, or can remembering become part of this enterprise moving forward?
Yeah, we were actually, Jeff and I were just talking about this the other day, about what role memory plays. For one thing, I think it's important for us to define what we mean by memory, because I think an ecological account of memory is not necessarily going to have the same definition as a more traditional account of memory, right? So you said it yourself, short-term memory, long-term memory, right? Those are very computational approaches, traditional approaches to memory, which presupposes that it is some kind of representation that is being stored on some kind of mental bookshelf, right?
Yeah.
But an ecological account of memory isn't going to be that, right? So I think, and this is just, I'm just spitballing, this is just me, but I think a more ecological account of it would be any semi-permanent or permanent change to an organism that changes future behavior, right? In which case, like working out and changing how strong your muscles are is a memory of a kind, because I've now changed the way that my body can arrange itself. I've now changed what my effectivities are. I can now pick up heavier things. So memory isn't going to necessarily take the same form in an ecological account that it would in a non-ecological account. That's like first and foremost, I think that.
And I think we can gain a lot by what we were just talking about, by turning it into a verb. Because when you talk about perception, one of the places that people define, the ways in which people define memory, traditionally speaking, is what happens when perceiving stops, right? So you've got the stimulus, you were just talking about stimulus before, stimulation hitting the retina or whatever. And then when that stimulation stops, the only contact you have with that is by memory.
Yeah.
But, perceiving doesn't stop. Perceiving isn't a function of stimulating cells on the retina. So when perceiving is necessarily occurs over time. Those are the only ways the transformations over time are the only ways to detect the invariants and separate those from the invariants. And so perceiving necessarily occurs over time. The perceiving is knowing, having epistemic contact with the environment. And remembering is just the fact that that goes on, that it continues, it persists. And that's the way I would describe memory. And I stole that from a paper from the late 70s from Turvey, Shaw, Reed, and Mace. Is perceiving is epistemic contact with the environment, and remembering is the fact that that's extended. It persists over time. That same contact, and I think some of the very early research on ecological psychology was on a concept called the occluding edge. That surfaces, when you move or when surfaces move, they occlude objects. But that occluding and disoccluding is a process that tells you about where those objects still are. It's not about, so you don't need to say, oh, well, I can no longer see my coffee cup because this thing is in front of it. It's that pattern of occlusion tells you that that cup still exists. You don't need to access memory so much as you are continuing to know. So, I think, and so for us, it's turning them into a process makes them continuous with each other. That perceiving requires acting, and it requires doing so over time, and all of this, they sort of blur into each other.
Yeah. I think another thing to remember is that we are not machines, we are systems. And so when you think about memory in a more classical sense, you think of, where did I store it in the machine, right? It's going to be some part of the machine whose job it is to record those events, and then I can remember them later by putting in a videotape or taking a book off a shelf. But in a system notion, it's going to be about, how does the system react? How does the system, how do things emerge out of a constantly interacting system? And if you change the constraints on that system slightly, different things will emerge. And so another way to think about memory is it's a way of changing the constraints on that system. So now a new thing will emerge. So it's a far more complicated thing than we're used to thinking of. The brain is this very complicated system of a lot of things that are acting as they do. But ultimately, it's a system. Those little individual neurons are just small, excitable bits. And so all of this stuff that we do is an emergent property of that. And memory could just be considered a constraint, right? We've changed one of the constraints on the brain, so now a different memory will emerge.
Well, that's a very interesting perspective. I mean, I never encountered that before. They can be considered as a constraint on the neural activity itself. And there are concepts like neural manifolds. I don't know how far they go into memory, but there are at least mathematical constructs around that idea.
Yeah.
So why is this perspective not very common? I mean, in every introductory psychology class, starts with short-term memory, long-term memory, episodic memory. The same with stimulus response and reinforcement and things of that sort. So why has this not percolated? I mean, this is such a I would say it's more evolutionary friendly way of looking at things.
Sure.
It's more naturalistic. So why do we have this divide, and why does this framework is still not dominant, assuming that this is the first textbook, which means that it's not very common, at least at the undergraduate level?
Well, one thing to remember is that if you look at it historically speaking, ecological psychology is still a relatively new idea, right? The idea of the machine metaphor is something that's been around since Descartes, really since before Descartes. So it had a lot of centuries to get its boots on, and it's pervasive. It's in everything. And so everything you're talking about, that stimulus response and the short-term, long-term memory, all of that kind of is a fallout of treating the mind and the body as separate and the body as a machine. And that's a very old idea that has taken very deep root. And it's not that that doesn't result in useful information. It can. There's a lot of really useful things that we've come out of that idea. It just keeps hitting its head on the ceiling. That's what we say about it, is it because it doesn't really get at all of the stuff that we are. It doesn't really get at our entire experience. So it keeps hitting its head on the ceiling. And as ecological, I mean, Jeff, what did you say? The 50s? Is my history right here? 1950s is when.
I mean, yeah, but that was just the very seeds, yeah.
The real first book on it was published 79.
Well, it was 1950 was the what do you call it? Perception of the visual world. I'm not even sure the term ecological was coined yet, but that was Gibson's first book, was 1950.
Right, and that's 73 years ago. So in terms of that, it's very young. So that's like thing the first is that it's young. And the second thing I would say is that people, they teach what they were taught. And so ideas have a way of persisting. Even though there might be a better idea, it's very hard to change one's mind. So that's my answer to the question of why haven't we taken over the world yet, is that we're working on it.
And this is something that we addressed in the first section of our book, that we go through the history of kind of mind science, and I'm now trying to remember the history of mind science is linear causality and also local causality. And because, how could you have one thing cause another that when those two things are separated in space and time? That's a very challenging idea. And for thousands of years, people said that's just impossible. You just can't do that. And ecological psychology requires both those things. It requires nonlinear cause and non-local cause, and or nonlinear outcomes and non-local cause. And so you're asking people to think differently. I mean, in a fundamental way, to take some leaps that at first glance don't make a lot of sense. And I also think that the more traditional perspectives, not just on perception, but on, memory is, like the box and arrow diagrams that you encounter in talking about memory. Okay, well, here's short-term memory and here's an arrow that goes to long-term memory. It's a pedagogical device to use metaphor. Oh, memory is like a recording device. So the eye is like a camera. Oh, I get it. The elbow is like a hinge. Well, yes, but mostly no. And it's it's because it's partly yes that people go, okay, but that's the first step. That's what we can get. We can get people to understand what the elbow is like by calling it a hinge. Yes, but it's not really a hinge. Okay, but okay, we'll get to that later. But for now, it's like a hinge. And so the ecological psychology is coming along and saying, yeah, but now it's time to get to the time to get rid of those metaphors, because they never were true in the first place. They were really handy pedagogical devices that persisted for thousands of years, that we need to discard. And that's a tall order.
There's this great Edward Box quote that I have written down on a piece of paper up on my wall. It says, all models are wrong. Some are useful. Right. And that's the thing. I think that machine metaphor was useful for a time. But since we've we've sort of, I think it's outlived its usefulness, and it's time for a new approach that takes a different metaphor and sees how that will go.
Yeah. I thought
I
this.
see it.
Yeah.
I'm sorry.
Yeah.
I see it like the way that Newtonian physics
Right.
got people to the moon. It turns out it's wrong,
Yeah.
but it was good enough to do a lot of things for a long time.
Yes.
But there are things it can't account for. And so, that's the Einsteinian physics. And I think there are parallels there, really strong parallels between the Einstein revolution in physics and the ecological revolution in psychology. I think they're asking the same kinds of things, because they're both field-based accounts of something that people were thinking about in terms of particles.
And let's be clear, Newtonian physics still taught in high schools. So
it's not wrong.
Even though all physicists are like, yeah, no, Einstein's is better, they still teach the Newtonian version because it's not wrong. It's just not as right as something else.
Yeah, and when you go to college and you start studying quantum mechanics, the same thing comes into your mind, like, how is it even possible? Because you are trained thinking in a very Newtonian terms, and suddenly you have these the Schrodinger's equation in front of you.
Yes, exactly.
Right. That explains a lot. So how has the response been about your book? Is it already adapted in institutions? Because we also need, it's not just about the book, right? It's also about the people who teach that book. Yeah.
So we went to a conference this past summer, and there was a lot of very positive feedback. Actually, where I'm getting the most positive feedback is from the students. I have had a lot of graduate students come to me or send me emails, or came up to me at that conference saying, I never understood this thing, and now I get my head around it. Thank you. Because we joke about it, but the whole goal was to write the book in such a way that I could hand it to my mother, and then she would understand what I did for a living. Right. So we wrote it at a level where you didn't have to know anything yet. You could start fresh and know nothing about any of this and still be able to understand what we do. And so I think it helped to have a primer. I know that UConn, they've decided, or at least last I heard, they had decided to make it a prerequisite for the program. So before you even start, they want you to go get this book and read it.
I did not know that. That's awesome.
Oh, they told me that at this conference. I'm sorry I didn't tell you that, but Jay and Claudia and I, we sat and we had this conversation, and Jay was like, well, from now on, they're going to have to read it before they even start here.
Well, maybe you're the first author. That's the privilege of being the first author, is you get the information first. That's great.
I should have shared it.
We have also gotten a lot of positive comments from people who are involved with the sports world in one way or another. It's been really strange.
Very big in sports.
People who are coaches or otherwise involved in working with athletes have reached out to us. We've had an MMA coach tell us that he thought the book was really important in how they like to take a science-based approach to coaching mixed martial arts, and he thought that this was useful and wanted to talk to us about that. We've had people from baseball, basketball reach out to us. That's been really eye-opening to me, that it's non-scientists, practitioners, which is just
unexpected.
Strange. Yeah, unexpected.
Yeah, very much.
This is actually the case when you talk to people in academics versus outside. So, for example, my father had a brain cancer. At that incident, I had to talk to a lot of doctors in a very short span. And in academics, it's very hard to find somebody who doesn't believe that brain is a computer of the sort of the kind of computation which happens inside my smartphone or my on my laptop, right? Those kind of computations. And then when you talk to these doctors, they do not believe anything of that sort. They look at brain in a very different manner.
Yeah.
And they don't have a convincing. They don't agree with a lot of academic output in terms of what we know about the brain.
Yeah.
Because they see patients doing very different things compared to what these computational ideas would predict. So they see contradictions day and night. in these theories.
Yeah, exactly. I think that's a really important point, is that the people with boots on the ground, right? The people who are actually out there interacting with people and seeing what the actual outcomes are very different from the people philosophizing about it, right? And I think and this is, I think, why this is taking off in the sports world, is because those mechanistic approaches just don't work. And so, or at least don't work as well as something else might. And so that's why I think it's taking off in there, is because they're getting better outcomes.
Yeah.
Or it's more in line with what they're seeing.
So I suggest an alternative title to your book called Decluttering the Mind, right?
Right. Sure.
Yeah.
There's a lot of titles.
Yes. I mean, it kind of gives it kind of de-mind washes you to, think freshly rather than from the same metaphors and from the same old perspectives.
Yeah, as Jeff mentioned earlier, that the first couple of chapters of the book are exactly that, right? They go through the hidden assumptions that we have in modern science, has all of these hidden assumptions that people kind of forget are there. And so once you make them explicit and start really unpacking them, you start realizing how much those assumptions are wrong. And that's why it's like, all right, so let's get rid of all of those and start over. I mean, I literally think my second chapter is called Starting Over, maybe my third chapter, I can't remember, right? Is called Starting Over, because you got to start over with new assumptions. And that's what the Gibsonian approach does. It's all brand new assumptions. Let's try again.
So do you often find these eureka kind of moment in students, while learning these things, like, oh, I thought that memories, and there are 3 kinds of memories, but now, oh, there's no specific kind of memory, it's memorizing. So do you have these moments in classes happening now and then?
Oh, yeah, absolutely. It's like one of my favorite things in the world of teaching is when you suddenly have a student go, that explains so much. It's completely different. I love that moment. That's why I teach.
And what would you answer to a student who comes to you like, oh yeah, you just wrote this book last year, and you're saying all that was written in those books which we have been studying for like 40 years is wrong? Do you think, like, what's the response to that student?
Well, I haven't had that experience because I'm not teaching out of my book at the moment. But I have had the experience of students saying, so wait a second, but I learned about this, the parts of the brain and what the parts of the brain do in a very mechanistic model. You're saying all of that's wrong. And what I always say is the thing that I said earlier. I said, all models are wrong, some are useful. And that model hit its head on the ceiling. And so we're going to try a different model and see if that works better.
Well, those parts of the brain still do those things. Those findings are not, they're valid. They're just valid in a different way for a different thing. And I think that's always important to keep in mind. So, and I trying to keep in mind what it is that those models are doing. I mean, if you're trying to understand, I don't know, the neurological processes involved in X, Y, and Z, well, then go for it. But if you're trying to understand, I don't know, reaching for a coffee cup, it's a different animal. Yeah. And trying to understand, trying to keep in mind what questions you're asking and what answers you're producing, and making sure that they align. I think that's a really important challenge. Have I gotten feedback about the resistance? I think some students have reacted that way. They find that, and I'm kind of evangelical about the ecological approach because I'm convinced it's right, and so I make that known. And I don't know. I've had people say, "Well, yeah, that you're just being intolerant of other views." Well, I mean, you can't have. It's not like you can create a Frankenstein's monster of psychological perspectives. You can't. Well, here's part of this. It's like the ecological perspective. You either accept it all the way through or not at all. And so,
although that doesn't mean that people don't try. I absolutely have talked to people teaching sensation and perception who teach affordances as if they're cues, and they're trying to sort of smash it into a more classical perspective. People try, but if you really dig into that, you can't.
Yeah.
But people do try.
This is what we are
Yeah.
yeah, go ahead. Sorry.
Well, I always say, like, I always find those approaches that try to take these incompatible perspectives and bend them together. They're like, oh, we're going to take the best of both worlds. And I always say, like, look, you're going to get something that's worse. You're going to I like beer, and I like, I don't know,
candy,
right? But I'm not going to make it like you wouldn't put them together. It's worse than it was before. You're I don't know. It feels like you're taking two perspectives that are
incompatible.
Incompatible, and you're satisfying no one, right? Taking the mean, sometimes when you take an average, you are representing nobody. And I think that's what's happening here when it's like, oh, well, it's this, you have affordances in the brain. It's like, no affordances in the brain.
Yeah.
So this is exactly what we are trying to do in the new book we are working on, and Dr. Wagman has a chapter on it, on affordances, on Gibson's legacy of affordances. We are trying to clarify some of these because, what I also figured while reading the literature, that the word affordance has been abused so much, and now the whole idea of us affordance to move away from representations in a traditional sense, and now we have representations of affordances.
Yeah.
A very regular term in published articles. So so how does it help anymore? So that's what we are trying to do right now. Yeah.
So I had a very funny interaction with a man who works at my university. He works in the computer science math department, and it turns out affordance, leapt over there and has taken root. And he's writing a paper where he discovered that affordances were not invented by computer science, but in fact may have been invented by this guy named Gibson, right? And I'm in a writing group with him, and he's telling this story, and I'm like, hey, yeah, is this a revelation? And he says, yeah, because apparently, like, the first person who cited it in computer science then gets cited as the inventor of the term over in computer science. And so they're citing that person instead of Gibson. And the term kind of drifted because of that. Yeah. And so this was him writing like a historical expose that this is not really that guy's term. And I'm like, yeah, no, it's Gibson's term. And here, read my book. Right.
Right.
He was astounded by it, right? And we've had a lot of conversations since about how, the term really doesn't mean the same thing in every place that it is used, because it has drifted away from its original intent. I think
it's a way to connect anybody who's interested in connecting perception and behavior, or at least many people who are interested in connecting perception and behavior have adopted the term. But there are lots of ways to connect perception and behavior that you aren't keeping the term the way it was meant to be.
Right.
And it has become a catch-all for I don't know, possibilities for behavior, but
not carefully understood.
Yeah, and just generally speaking across the board, and so it has been, and I think part of this has to do with this blending of perspectives. There's the embodied cognition perspective that emerged in the early 90s. I personally, I think, guilty of doing this, where they said, oh, well, we're gonna take cognitive psychology and we're gonna combine it. We're gonna sort of bend this together because clearly perception occurs in a body, but that body does the representing, and all of a sudden it took the ecological concepts and twisted them in a way that fit a more traditional cognitive perspective. And so But the overall point that perception and behavior are related is a good one. And so I think people said, yes, that's the way to go. And so I think there's all of these offshoots of the term affordance that people have used, because the term it's a really useful term, and people have adopted it for their own in their own discipline and their own way. And then it's like you lose track of who actually came up with it, and
Right.
it's one of those concepts that is so valuable and important that
Everyone wants to borrow it.
It keeps reemerging, but then you lose track of where it came from and what it did, and so.
I joke with my friends that we need an affordance oversight committee, and every paper saying affordance will be cleared by that committee before it gets published.
Yeah. I like the idea.
Yeah.
That sounds good. I'll be on that committee.
So, so this kind of dissatisfaction with when you said that, hitting the ceiling, I think it's across the board. So that's why even the hardcore representation and neuroscience community is coming up with articles now. For example, the brain needs more, neuroscience needs behavior, for example, one of the very highly cited article in recent times talking about why neuroscience paradigms need more behavior, because we ultimately want to understand behavior and not what neurons are doing, just like that, right? And then we have books like Buzaki's, The Brain from Inside Out, and Scott Gaffin also has a book along those lines. But what I'm surprised most of the times reading those books is there's very little mention of Gibson, and a lot of times they are rediscovering some things which Gibson did a lot of good formalization for. So there's definitely a lack of reading of ecopsych and other communities. It's pretty apparent, even though they're realizing what Gibson realized in earlier times.
Yeah, this is a big part of why I wrote, why we wanted to write this book, because of exactly that, because we've got a PR problem, right?
You got a PR problem, yes.
Yeah, where, a lot of the writing in ecological psych is just, it's just so niche, right? Like there's only so many people who are going to understand that paper. Yeah. And there's nothing that is written for the layperson, or not enough that is written for the layperson that you can hand it to someone who's struggling with something and say, oh, I think I might have the intellectual piece that will help with the thing that you're doing. There's just not enough written at that level. And so this is a big part of why we thought this book was needed, was because you want to be able to hand something to somebody and say, here, this will help you solve the problem you're having.
I think one of the reasons people like Gibson's books, especially his last one, which is the Ecological Approach to Visual Perception, is it's written in a very folksy, easygoing style. Yeah. And it's fun to read. It's kind of pleasant. He's Midwestern, American Midwestern, and it's very, it's casual, but it's not very tight. And so then a group of early ecological psychologists, Michael Turvey, Bob Shaw, Ed Reed, and Bill Maith, came along and did the tightening. But they wrote series of articles in the late 70s and early 80s, but they are dense.
Very dense.
Really dense.
Very dense.
50 to 60 pages of hardcore philosophy. And so it's really hard to kind of, where do you go to introduce people to this field? Do you go sort of folksy and easygoing, or you need to go dense and philosophical? And so I think that's the sort of vacuum we tried to fill with this book, was sort of in between these two as best we could.
Yeah, very much.
I see. So one other criticism, in general, which often comes up when we talk about ecopsych, is like we are not very physiological. We are not interested in physiology as much as in behavior and perception and action. Is that really true, or is it just that we are at infancy, or in general the field is we really want to establish the principles first before moving or before going much deeper inside the brain, before interpreting what the neurons are doing? Are you trying to clarify things, or we are never planning to go that deep in physiology?
You can't really go and explore physiology without a guiding principle for what you're looking for. If you go in expecting the brain to be a machine, then everything you see, you're going to interpret through the lens of seeing it as a machine. If you go in expecting the muscles to be hydraulic systems, then you're going to go in interpreting everything you see as a hydraulic system. So if you want to have an accurate understanding of the physiology, you have to first understand the philosophical guiding principles. So I don't think the ecological perspective is avoiding physiology. We just, that's not first. And there's been some really incredible things that I have seen in physiology. I was at a conference, I'm not going to remember where, even who presented it. What a bad scientist I am. Anyway, but it was looking at the muscle fibers and looking at the nerves going through there and seeing how every single time that muscle moved, and any time that it was being energized, those nerves, they were recombining in different ways, right? Which is exactly what the ecological perspective predicts, is that we arrange ourselves every time to achieve a goal, and we're going to arrange ourselves slightly differently each time depending on what the goal demands. And so you can see it on these physiological, very micro levels, these muscles combining in different ways, and the fibers, this time peeling off over here, or that time peeling off over there, which is what we would predict. But if you aren't going in looking for that, you're not going to see it.
Yeah, I think that we want to understand the principles, because the principles apply in a way that extends across anatomy. I mean, we can talk about how the human hand is special, that it does certain things, but you can do those things with a foot. You can do those things with, if you can pick up a coffee cup and drink with 2 feet, if with no hands, if you want. It's just a matter of it's getting the anatomical components to cooperate in a particular way, and I think I think the same thing is true about brain science. This is I think a really, really exciting recent perspective is one from Michael Anderson and his group.
Yeah.
About the brain activity as synergies, in the same way that getting, the muscles of the separate legs to cooperate to walk is a synergy. So you're getting different brain components coordinating in a temporary, task-specific, flexible way, and then disappearing and then coming again from the other side to do a different task. And it's not about the brain piece per se, it's about the coordination that's being generated, and that coordination that can be described by these principles. So I guess if you understand the principles that apply, then the pieces are less important. They're not unimportant.
Yeah.
They're just less important. And so to try to start the explanation with the pieces, you kind of miss the point, I think.
So there's a possibility that once ecopsych is more clear, or the foundation is laid, then we'll be able to interpret a lot of data or a lot of findings which you already have in that new meta-theoretical framework.
Yeah, in fact,
am I right?
that. Yeah, you see that all the time. I mean, the people going back to the same data and saying, oh, but if you just think about this as an ecological thing, you'll see a completely different thing. You'll see a completely different outcome, or completely different. So the example that I always give is the studies where they put weights at the end of the sticks, and if you ask people to perceive the length of the stick, right, they will get it wrong, right? Because if you put a weight at the end, it's going to feel like it's longer to them.
Yeah.
You ask them, but if you then recode that data using rotational inertia instead of length of stick, suddenly perception's good again. And I think you're going to see a lot of that, right? Where you go back and you say, okay, but if you think about that from an ecological perspective, suddenly it all makes sense, or it collapses into fewer variables, or there's that same data makes sense in a new context. So I think some of it, but then some of it was just, there's research that was done using the wrong questions and the wrong assumptions. And so that data isn't going to be useful from an ecological perspective. You need to do a different experiment, right?
Yeah. I was trained as a biologist, and I read Dobzhansky's quote that nothing makes light in biology except in the light of evolution. And when I read about ecological psychology for the first time, that was a eureka moment for me, because this was the first thing in psychology I was reading which made sense in the light of evolution, because everything else I read before that had no basically evolutionary roots.
Yeah.
So suddenly Gibson came and put the whole perception, action, cognition, in those evolutionary roots.
Yeah, I love that. And I also think about that evolution component of it, because there was a time when we were not this very complex thing. At some point back in evolution, we're going to be a single-celled organism, or we're going to be a sea slug, or whatever our very far ancestors were. And that needed to evolve into this. So you can't tell me that at some point we like woke up one day with the ability to have these complex computations and representations we needed to be able to perceive when we were single-celled organisms. We're not going to make it to this without that.
Right.
So why have a second layer? Why do a different thing? Just doesn't make sense.
I think the other side of that is that I think you can take a evolution by natural selection perspective a little bit too far, and then start ascribing functions to things that emerge for other reasons. So I think that evolution always has to be in the context of a larger physical context, thermodynamic context. And so, I think Gibson definitely was inspired by evolution and wanted to get this is why, a lot of the picture on the cover of his last book was a bird. All right. I mean, he was talking about other species and how there was a change in abilities that through evolution, and that the human perceptual abilities are going to be continuous to those of other animals. But at the same time, other people have picked up on this more so, but that all has to be in this context of constraints.
No, this is so true, because like we can come up with computational models of vision and error correction, while for us walking speed, or for me, with the speed of my hand grasping the glass. But when the same thing you're talking about a bird, right, which is like the bird is flying at a speed of 100 miles an hour, like what would an intermoder do? The bird would just crash. It has to, it just cannot use those models suddenly. So is it using a very different kind of cognition?
Right. And it doesn't make sense to use a different kind of cognition for a bird than for us.
Because exactly.
And you were saying earlier, like, where are we going to draw that line?
Yeah.
These people do it this way, and this group does it that way.
Exactly. Yeah. So what are, according to you, some of the challenges the whole ecopsych community or the ecopsych field has to overcome to make this perspective more common or mainstream, you can say? Like what are some of the tasks which we need to embark on? Of course, the textbook is one of the first steps.
I mean, for my money, and I've said this for a lot of years now, we need ambassadors. We have a PR problem. People don't know about it. And I think when you can explain it, when you can do it, it's just so clearly better. I wouldn't be an ecological psychologist if I didn't feel this way, but it's just so clearly better. And it's just so clearly more consistent that if you can get more people to stop and listen. And the problem is that I don't think you can get that for people who are established. I don't think you're changing the minds of somebody who's been doing a computational approach for 20 years. That person isn't going to change their mind.
Yeah.
But if we can teach this to college students, if we can teach this to, or even get into more complex causality younger than that, right? Get high school students thinking about nonlinear causality. It's crazy, but that's what we need. We need exposure, because with exposure will come more buy-in, because it makes sense. It's a more coherent strategy. At least that's my money.
Yeah, I did something I always think about is the pedagogical value of metaphor versus the truth. and I don't know what to do about that, because it's so simple to say the eye is like a camera.
Right.
Although actually that doesn't even work anymore. That's more true for like old school cameras. But anyway, it's so simple to say that and have someone go, "Oh, I get it," but you're lying to them up front in order to get them on board. And so the metaphors at play in a more traditional approach to perception, action, cognition are much more tangible. They're much more, they're stickier. They make sense. You can, and so that's what we need. We need to find
better metaphors.
Yeah, crowbars to sort of say, no. This is the way we describe this process. We need other examples, because it's very squishy. And I think when you look at it in totality, you see that it all makes sense, but it's hard for that first step. And I think that's one of the things we're trying to do with the book, is to say, look, there's maybe this first step can be a little bit easier.
Yeah.
So I have been thinking about this, Dr. Wagman, like with George Lakoff's book on metaphors we live by, starting with that book. So we definitely cannot get away with metaphors. Our thinking is metaphorical. But I was thinking of, having this piece, and probably, we can collaborate on that, where we actually introduce new metaphors and actually kind of box some metaphors, like these are the metaphors we need to get away with. And these are the metaphors which are at least more helpful. They're more truthful comparatively. Definitely we cannot we don't know what truth is, right? We know what is more true than what is less true.
Right.
Do you think there's a scope for that?
Or more pragmatically true.
Or more pragmatically true. But given that we think metaphorically, I think just saying that these metaphors are wrong or are hitting the ceiling, it might be better to actually provide some metaphors, like, okay, let's try to think using those metaphors. And does it make life better?
I mean, I agree entirely. I mean, as a teacher myself, I'm always reaching for a metaphor. I'm always trying to give something to lean on it. And we do it in the book too. I mean, Jeff, in the chapter you on the water bottle, swooshing the water around in the water bottle, that was a metaphor, and it's a great one. And that's because we are concrete thinkers, right? And this is just a human thing. We're gonna like a metaphor. And I think the difference is that we don't want to substitute the metaphor for reality. We want to say, let's start with the metaphor so you can understand what we're talking about, and then I'm going to tell you the ways in which it's not like that. Right. And I think that's that second step of, and then I'm going to tell you the ways it's not like that, is where the breakdown is. Sometimes you want to latch onto the metaphor and then have that be your understanding, but all models are wrong.
So can we, does it mean that we can actually have a metaphor-free way of thinking about perception, action, cognition? Is it possible?
I doubt it. I mean, maybe I'm being cynical, but I doubt it, because it's going to be humans trying to understand it, and humans are metaphorical thinkers.
No, I think we just need to find better metaphors. This is the value of the polar planimeter. It's one of these. It is it's a measuring device that, but it's an analog measuring device, and that's what we need. We need analog metaphors. So the polar planimeter is an analog device that measures the area of an irregularly shaped surface, but it does so without doing the calculations that you would normally do to do that. And I think that's really what we need. We need analog metaphors.
Yeah.
But then some of our friends will come and they'll say, like, yeah, you're completely right. The brain is an analog computer. That's what we meant all this time.
No.
Maybe so.
Okay.
I think you're also trying to overcome some this isn't quite egocentrism. It isn't quite. It's about the feeling that humans are special, and humans are special, but they're special in the same way that any living thing is special. So if you say to someone, I think I have said this to students before to be provocative, I said, look, you are more like cockroaches than you are like a computer. And that's like, they go, no, I'm not. Well,
Yeah.
And so that's a very strange, because a computer is clean and crisp and it's fast and it's something, and a cockroach is this squirmy, creepy crawly bug. But
Yeah.
and it's just strange to think to take away the beauty of some of these metaphors. You're saying, no, actually the metaphor is quite ugly. And let's embrace that. Let's embrace the ugly.
That's a really good approach, and that's kind of eye-opening as well. Right.
Get that on a t-shirt, embrace the ugly.
Yeah, I like that.
I think we need some t-shirts, eco-psych t-shirts.
There we go. I'm in.
Like I'm cognizing. Beware, I'm cognizing.
We could sell them at conferences. I love it.
Oh, had we had this discussion before, I could have planned something for this upcoming ICPA. By the way, are you both coming to ICPA? I know Dr. Wagman is coming.
Yes.
Oh yeah.
Oh, that would be great.
Awesome. Looking forward to it. Yeah.
So, Dr. Blau and Dr. Wagman, it was a pleasure discussing these issues with you. Am I missing something which you would like to add to our conversation so far?
We didn't talk about Fred. I think this might be the first interview where we didn't talk about Fred. Our book has a main character who's
I see.
all the adventures, and which is the thing that makes it unusual from all other textbooks.
Yes. It's kind of a mascot around which
that's right. That's what I really want. I want t-shirts with Fred on them.
So so we need to figure out like how Fred looks like though.
He's a circle. He's a circle with little legs. He's very simple.
Yeah, it's on the cover. It's on the cover page as well.
That's right.
Yes. So for viewers,
Julia was quite adamant. We wrote the book, and our publisher said it's time to pick a cover, and Julia was like, "I want Fred on it." And I was like, "Okay, if you feel that strongly, we'll go with Fred," and we did.
And I was always wondering, while reading the book and looking at the cover, like why is it like that simple? Why is Fred so simple? The minimalist, I would say, the minimal Fred you can find.
Because that's exactly the idea of it, is that it is so simple.
Yeah.
That you don't have to go into these complex computations to understand the relatively simple act of picking up a coffee cup, or avoiding a bee, as is on the cover of the book, or trying to get an apple from an apple tree, which is the example that I used in those first couple of chapters. You don't have to get into super complex mechanics and computations in order to do all of that. It has to be simple.
Right.
Also, because I use him in teaching, and he's much easier to draw.
That explains.
Yeah.
Artistic capabilities constraining characters, choice of characters.
Yeah, but I like the metaphor.
Yeah. Well, thank you, Dr. Blau and Wagman. One thing, if you have some resources for viewers to read through your own work, other people's work, some books, please could you send me the links, and I would post all those along with this video on YouTube.
Sure. Thank you so much.
Send us the link.
Yeah.
Yeah.
We will. I will.
Thank you so much.
Thanks so much for your time, and it was a real pleasure.
Too.
Yeah. Bye-bye.
Bye.